In the last video, I have explained about this problem. So here, so this is what the structural definition of this system, geared system under the node formation. So this LA and the LB dash and the L1, L3. So these things you have to be clear. Here, let us take the given details. Here, the gear ratio is given as 3. That is, the ratio between the pump speed being 1/3 of the motor pump. So this is what. So motor pump is the input one, and your pump is the output. So here that becomes 1 by 1 by 3. So that becomes 3. And the diameter, the first one is 60 mm in meters, and the length 300 mm, and in meters 0.3 meters, and its moment of inertia. And this is not d square, actually this is d2. So that is 100 mm, 0.1 meter, and L2 is 600 mm, so that becomes 0.6 meters, and its moment of inertia, mass moment of inertia is 1500 kilometer square. And the rigidity modulus of the shaft material is given as 80 giga-Newton per meter square. So 80 into 10 power 9 Newton per meter square. The giga stands for 10 power 9. Here the original system has to be converted into its equivalent system. So we will take the diameter as D1 as 60 mm as equivalent diameter. So the mass moment of inertia of the equivalent diameter becomes IB dash, that is equal to IB by G square. So here this is 1500 is the actual that is mass moment of inertia of the impeller. But when you convert it into an equivalent system, its moment of inertia to the equivalent rotor B will become this one. So 1500 by its gear ratio is 3 square, so 166.7 kilogram. So this is important and a different step other than this other 2 rotor and 3 rotor system. And similarly, the additional length of the equivalent shaft becomes there. It is, if it is having only 2 cross sections, so you leave this G L2 into this is a bracket whole power d1 by d2 whole power 4. Okay, so here since it is a geared system, we have this gear ratio extra, that's it. So you have to substitute in the torsional equivalent shaft formula, and you are going to find out the length of the equivalent shaft, that is 0.7 meter, right. This L becomes 0.7 meter. And now the total length of the equivalent shaft becomes L1 plus L3, 300 plus 700, so it becomes 1 meter. And since it is a single node forming at N, this LAIA equal to LBIB as we have in the 2 rotor system, and from which we can find out LAIA substitute 400 kilogram meter square, and IB is equivalent mass moment of inertia for the rotor B, so 166.7, and here we know this L B is nothing but L minus LA. So you just consider this one, and finally you will arrive with LA, and you know the frequency of the torsional vibration or any vibration is equal to 1 by 2 pi root of Cj by LAIA. So you know LA and you know IA also. The only thing is what you have to find out is J. So J, the mass moment of inertia of a polar moment of inertia of a equivalent shaft is pi by 32 d1 power 4. So you are going to take this d1 as 0.06, and you have to find out. So 1.27 into 10 power 6 meter power 4, substitute everything, and you will get 4.7 hertz as the answer. So the thing is that this diagram is very important, then only you can understand it, and only the finding the equivalent mass moment of inertia and the length of the equivalent shaft. This is what very important.